Welcome back to my channel. So, by seeing the thumbnail, you have already known what we are going to learn in this video series tutorial. So, the topic for the day is Geospatial Analysis with Python. Many of you have seen or listened or known about this geospatial analysis can be done with Python. So, Python is a programming language that can be done for various purposes. For in this case, we are going to do geospatial analysis with Python. So, before going to our study material, we want to know what we are going to do with. So for this case, we are using spatial data. Before going to spatial data, let me give you a slight concept about the spatial data. What is spatial data? What is spatial data? The data are information that generally defines the geographic location of certain feature or boundary. So if you are on a certain location, it might be you are on a house, or you are on a street, or you are on any other location. You want to share your location with your friend. So what will you do? You go to Google Map or OSM, OpenStreetMap, and select the latitude and longitude, and give to that coordinate point to the friend. That is the spatial data. That means you are giving your location, that is location data, to your friend. You are sharing a spatial data. So second point says spatial data are usually saved as coordinate. Okay, they are usually saved as coordinate, and they can be mapped. This coordinate can be mapped. That can be mapped using some GIS softwares, and then create a visualize that geographic coordinates. So usually two types of spatial data are there. That is vector data and raster data. You can see in this picture here. You can see the vector data. This is the real ground object, that real feature in the earth, and you can convert this into two type of data: is raster data and vector data. So you can go to raster data. Raster data is created by capturing the images. These images is captured through camera, or that is you can go through it, aerial photographs, drone, satellite, and then the satellite then converts this image into grid of pixels. You can see a number of pixels, and this individual pixel has certain values, that is RGB values. These RGB values are stored in each pixel. Also, you can go with digitization. For the digitization process, you can go with individual adding point, line, and polygon. Point can be defined to show your point data, that is tree or your location, and line can be drawn to show some certain feature like road, that is river, and many things. And through the boundary, that is polygon data, you can show a certain boundary. Maybe that can be the boundary of your country, or maybe that can be the boundary of your forest area or anything. So I want to ask you a certain question. So many of you are using GIS softwares. So which software you usually do for geospatial analysis? I guess every of you are the beginner for geospatial analysis with Panda, but you have done already geospatial analysis with some certain softwares that are freely, or you have paid for that, or you have, in case of many users, there is a crack version also available. So write in the comment section which software you are going with, you are using your for spatial analysis. So maybe ArcGIS, it is a you have a paid version of ArcGIS by ESA, right? So many of you are using crack version. So maybe many of you are using ArcGIS, and other is ArcGIS Pro. I guess certain of you are using ArcGIS Pro and QGIS. QGIS is an open source software. You have many plugins, and it makes the work easier in QGIS. I usually use QGIS for my case. And let's go to our topic of today: geospatial analysis. For geospatial analysis, we are going to use mainly Geopandas library of Python. Geopandas, what is Geopandas? Okay, so Geopandas is an open source library and enables the use of manipulation of geospatial data in Python. So you have already known, you have done geospatial analysis with different GIS software, but in case of using Python, we have to use a library, that is Geopandas. It can make our work easier in the manipulation of geospatial data. So another is GeoPandas extend the data type used by pandas to allow special operation. So if you have already known about pandas, you are using pandas in pandas library in Python. So GeoPandas extends the way you are using pandas, so you can enable special operation through GeoPandas. And Geopandas combine the capabilities of the data analysis library pandas with other packages. So with Geopandas, you can import many other libraries, that is Shapely, Fiona, Matplotlib, and you can visualize more accurately and more efficient way of your spatial data. So for installing Geopandas, you have two way. Either you can use Conda and Conda for channel. So for this code Conda for, you have this Conda install -c Conda for Geopandas, or you can use directly using pip install. So I usually use pip install for Geopandas installation. And in this tutorial, what we'll be using mainly, our topic is geospatial analysis with Python. So we'll be using obviously Python, and then we'll use either Jupyter Notebook or Google Colab for writing our code. So code editor, in case of this course, I will teach you on how to use Google Colab. I will not use Jupyter Notebook. You can search on YouTube anywhere how to use Jupyter Notebook, and you can either do by Jupyter Notebook also. But in case of this tutorial, I will be giving you the tutorials, some basic tutorials on Google Colab, and we'll use that Google Colab library, Google Colab editor. So also I'll give you some assignments. I guess in this tutorial, not only I will talk, but you will also do the work that I have given in the assignment. If you are not going to do the coding activities that is in the course, then you are not going to learn. So obviously you have come to this video to learn something. So do coding, pause this video and start coding. And if you have some problem, you can write in the comment section. So I'll try my best to give you the possible answer of your questions, answer of your problem that arises during the coding. So I guess after each session, I'll give you some exercises, and you can do the exercise and give the output in the comment section. So what we'll be learning in this session, the course content of this session, we'll go through Google Colab walkthrough. So for this case, we will be using Google Colab as our code editor, and I will go with Google Colab walkthrough at the first session. And then Geopandas installation. So we'll install Geopandas in our Google Colab, and then we'll also we'll go with first reading the vector data, and then writing the vector data. That means we have some vector data in our computer, maybe in our Google Drive or anywhere, and we'll use that data, and then also we'll do some geospatial analysis, and then we have to save that data. So that is writing vector data in Python. So after that, we are going to visualize our data. So we will be creating a beautiful map visualization using Matplotlib library. And then we'll go with the attribute data, working with the attribute data. We have some attribute data in our save file or GeoJSON file format, and we'll be using this attribute data to work with it. We will manipulate the data. We'll add some data in our attribute file attribute column. Also, we'll manipulate the geometry. So we'll learn about the geometry manipulation. We'll work with the geometry. How do we create a geometry in Python? So using some, if I have some location of the individual data, and I can plot a geometry using pandas, not using the simple manual technique in QGIS or ArcGIS. We have already done digitization in ArcGIS or QGIS, but we will use Python library in this case. So I guess you all are ready to go for coding. So get ready, get set, and let's go for coding. So I guess I will not only write the code, but you will also write along with me in this tutorial. So get ready for with laptop, keyboard, mouse, I guess. So let's get our hand on coding. Let's go. Okay, let's start our first session. The first session will be hands-on Google Colab. We'll be using Google Colab as our code editor for this purpose. Let's go to google.com and search for Google Colab. Okay, you can see in the first result collab.research.google.com. I will click on this, and after this you can find a in your browser this type of interface. I will click on new notebook. This will open a new collab where you can see the tutorial new notebook. So I don't need this all, so I'll go with file. Okay, and I will rename this as Geospatial Analysis with Python. So you can see this is the ideally of Google Collab. That means this is the Python file. You can see this is the Python file. So for Python, I can print hello world. You can try it in your Google Collab also. Please, I want to say to you that please do as I do in this desktop. You can do in your one desktop, but at least try to do. Don't just watch the video. It will take some time to load at the first time. So you can see this is the Python yellow world. You can see here you can add your data. So for that case, I guess you can click on this. Either you have two types of data. You can two types of way you can add your data. The first way is directly uploading the data here. So for that case, I will go on clicking, and I have this folder where I have kept all the data. So for the first case, I will use .ssp format. So I will click the whole SSP data. So you have for SSP you have this type of data. Municipality, this is GeoJSON file format. I'll also add this also. Okay, and then open. It will take some time to. So you can see in there uploaded files will get deleted when this runtime is recycled. So every time you recycle the data or you reopen the Google Grab, this data on your left side will be deleted. So if you want your data to not be deleted, so you can mount the drive. You will be using your Google account for the Google Collab. So I will add the data in my Google Drive and use that Google Drive to get all the data. So for that case, you can see here it is uploading. So for that case, I will click on this third button, mount drive. What it will do is it will connect our Google Colab with our Google Drive. So in my Google Drive, I will added the same data as data. So I'll connect the Google Drive with my Google Colab, and I will extract all the data from Google Drive. And that will make me easy whenever I use the data. It will directly obtain from the Google Drive, so I don't have to again add the same data in Google Colab. In that way, you can also use that way in Google. So it will take time to reconnect. You can do it any way you want. I prefer mounting with drive. Okay, it's taking some time. You can see mounting the Google Drive. Once Google Drive is mounted, you can see you will see a next folder item here. Okay, you can see the drive. Okay, this much is sufficient. So in my drive, I have a Geospatial Analysis with Python, and here is the data. Okay, this is the end of the first session on Google Colab, introduction to Google Colab. So what I have done, everything you have to do on your one PC. Otherwise, you will not learn anything from this course. Let's make this course useful. Let's go with the course. So let's start our next session on installation of Geopandas. Okay, so we are again with the next session on Geospatial installation of Geopandas. So I will delete. You can delete directly from here. You can select the cell. This is called cell. This individual. This is called cell, and you can delete from here, or either you can add code individual cell. You can add as many as cell you want from here. So what I will do is I will first write the text that is that will help you learn again. So I will give all this code at last in GitHub repository. You can find on the description. Also you can find the link to the data on the description. You can find the description data link on the you can see data here, that arrow sign here, and you can get the Google Drive live link. So you can click on that and download the data, and you can upload it on your Google Drive. So I'll use this as installation of Geopandas. What this text does is it will not run when we enter. So to run the shift code, you have to enter on your keyboard. So I will add for the case of installation, let me pip install Geopandas. So we'll be using pip install and then shift enter. So it will take some time to install the Geopandas. So it has already successfully installed Geopandas. After that, we have to import the Geopandas. We have installed the Geopandas, but we have to import the Geopandas package into our program so that we can use it. So for that case, I will import Geopandas, and I will use the as a shortcut as GPD. So as GPD means I will use to import Geopandas as GPD. So it will be stored as GPD. And then I'll also import Matplotlib library. So Matplotlib library can be used to visualize our data. Matplotlib. So you can use that library at the map visualization session, but I have already installed here. You can do at any time you want as PLT. And then what we have to do is we have to make this Matplotlib as inline. Matplotlib inline. So I will run again this cell. So this is the session where we have learned about installation of Geopandas. Let's go to our next session on reading vector data. Okay, we are on the next session of reading vector data. So for that case, what we'll do is we'll go with our drive. So here you can see the drive. In the drive you can see different type of data. So we'll select the shape file. For the shape file we'll select the shape file, and then here you can see three dots, or you can click on your mouse the right button and then copy the path. So what we'll do is we have the municipality wise data of whole Nepal. So what we'll do is we will store this data as municipality is equals to GPD Geopandas. So we have already imported Geopandas as GPD dot read underscore file, and then we'll give the link of uh, the copy path of the path of the file. So let me run the cell. So it has already imported. So we have imported read the say file format. In order to read the GeoJSON file format, you can see GeoJSON file format here. So I'll copy this municipality underscore GeoJSON equals to same. You will use the same code, and you will only change it as sorry. Oh, sorry. Here I guess I get some mistake. You have to sorry. Copy and then paste. this will paste the, and then I will again copy this here, paste as municipality underscore geogestion, and you can see the path is same, but our file format is geogestion. Okay, now we have imported both GeoJSON file and shape file format, and we have saved the shape file format as municipality and GeoJSON file as municipality underscore GeoJSON. So this is the next session on reading the vector data file. The next session we'll learn about the reading metadata of our shape file or GeoJSON file format. So let's go to the next session. Okay, this is the session where we will be reading the metadata of our data that we added in our uh, in our program. So for that case, we'll go with the first is we want to know how many data are there in our shape file. So for that case, we'll use len of municipality. What it does is uh, it will show the length of the file, number of files. It will show the number of files. So we have 775 municipalities in our data. Let me first, so okay, so after this I will add a text, and I will give this as reading vector data. So in this way it will be easier for you to understand when I add this in GitHub repository. You can download this and use reading metadata, so it will be easy. So what lend, okay, I will go. So with this hashtag can be used to give the comment in our Python. You can be used to give, you can give hashtag to give a comment on the Python, so it will not run. So only this length municipality will only run. So the next is we'll see the header file. So what is our data? Municipality dot head. It will show the first 5 data of our database. So we have province name, district, palika, type of palika. Okay, we have 3 types of palika. Three or more than 3 types of palika, mainly gaupalika, nagarpalika, mahanagarpalika, upamahanagarpalika. That type of palika we have distinguished the type of palika, and you can see the type of the geometry of the individual palika. So it is polygon. Every geometry is polygon. Let's so you can see the geometry type by another code also, municipality dot geom underscore type. It will show the geometry of our file. So you can see all the geometry is polygon. Now we'll go with the shape means the how many feature, the example, or maybe how many municipality are there and how many type of data feature are there. So you can see here, this is the number of this. You can see individual row is the number of you can see according to the shape, it will show the number of rows and column. So municipality dot shape, so it will show 775 rows and 6 column. You can see 1 2 3 4 5 and 6 column in our data. And after that you can go with the coordinate reference system of our data. So for that case, we will go with CRS, municipality.crs. It will show the coordinate reference system of our data. So it is geographic coordinate system. EPSA is 4326, WGS 1984. You can see their data means World Geodetic System 1984. So ellipsoid WGS 84, prime meridian is Greenwich. So you can see that coordinate reference system of our data. And we're gonna go with a municipality type. So it is a Geopandas and it is a geodata frame. The type of data is geodata frame. With this, we have read all the possible metadata of our data. Now we'll go to the source session where we'll visualize our data. We'll create a map using the data that is in above. This is the data, and we'll use this data to visualize our data. So the exercise first for you is read the file rupande.ssp in your data folder. I have given the save file as rupande.ssp in your data folder. You can see and show the shape of the file. So you can see this. Show the shape of the file. I have already given the code. Also, you can see there and get help from that. And find the length of the file, and also find the geometry type of the data. So we are on the next session of visualization, map visualization, and here we will be visualizing our data. So for that case, we have already imported municipality data here. Here municipality, as we have saved it as a variable name municipality. So what we'll do is we'll use a Matplotlib library. Matplotlib, we also imported Matplotlib library here as import Matplotlib library. So let's go with the Matplotlib library. Here I will write a text. Sorry, after this I will write this as a text, and I will give this as new folder that will be named as map visualization. Let me delete this. And for the map visualization, we'll use municipality.plot. So what it does is it will plot the data, geographic data. So you can see the map of Nepal plotted with every boundary of our palika inside this. You can see the boundary here. So if you want to remove this color and you want to show only boundary, so for that case you can use municipality dot boundary dot plot. It will only show the boundary of your data. It will take some time depending on your computer. So since the file is huge, it is taking some time. Again, you can see only the boundary of your data. And after that, if you want to increase the size of this plot, you can go with municipality dot plot, and inside plot you can give fig size equals to 10 by 10. So I will go with 10 by 10. You can change according to your need. So I will go with 10 by 10. You can see the size of the figure changed to 10 by 10. So after that, what we will do is we are going to color our data. So for coloring, what we'll do is we'll use a CMAP. So CMAP means color map in Matplotlib. You can use the you can see the documentation here. So we'll use a CMAP in to color the map. So for that case, what we'll do is municipality dot plot, and we'll plot according to province, I guess. For that case, I will write PR underscore name according to province name, and the CMAP will be the color format. It is a combination of the color, and color will be magma. we'll use magma color format, and also we'll also add the legend true. So what it does is it will plot according to province name. So it will give the different color to different province. We have 7 province, and it gives province to different color to different province. And then we will use the color format as magma. You can see different color format here. I'll give the link in the description below. You can check this link as well. And then legend equals to tree means we are giving the legend on the basis of PR name. So what we use on the basis of PR name, we are giving our color, we are plotting our data, so it will give the legend on the basis of the PR name. And also you can see if you want to remove this axis, if you want to remove this axis, what we'll do is we'll import this, we'll create a new variable where we'll plot the data municipality plot. And then what you want to do is so we add this same here, and then we will axis dot set underscore axis underscore off. This will only give the map, it will remove the axis, so it will only give the map along with legend. So I'll remove the legend as well. So removing the legend, so it will only give the map. So you can save this map, save images. So I'll save here in my here, and I can see this is the map. So if you increase the size of the map, so I'll increase the fig size equals to, in my case I guess 15 by 15 I will add for now. So I'll increase the size, so I'll save this here. It will save the map in PNG format. Okay, so in this way you can save the data. So I'll also like to say that this is not the original map of Nepal. So I have been missing some part of the Nepal, so I'm sorry for that. I could not get the original shape of file that has all the municipality level boundary. So if any one of you watching my video has the shape file of the boundary, please give the link to the data on the comment section. So so that way I can get, and many of our uh, viewers who are watching the video can get the data, accurate data. Okay, this is the end of this session where we have visualized our data. Now we will go with writing our data. Okay, the second exercise, I have already given the Rupandhi district, and you can visualize the Rupandhi district on the basis of Palika. You can visualize the district on the basis of Palika, and show all the Palikas of Rupandhi district in OMF format. This OMF format you will learn at the last. So this is for those who have already known about this, or you can do this course in the last also. So for the writing case, what we are going to do is we are going to write our data on our previous file. So I have already okay, let me first import this as a different data format, and I will save it as a different data format. So I will go with data, and let me import this municipality as sorry, writing data. Let me import this as abc equals to gpd dot read underscore file. So it will read this as gpd Geopandas. Now what I gonna do is I will create a new folder here, create a new folder that will be named as output. output, and inside output I will save this. So for that case I will copy the path, and then what I'm gonna do is I'm gonna save this in the folder. For that case I will be using abc is our file that we are going to add, and we will be add to file that will convert the data into file, and we are going to save this file in this location. And what we are going to save this as, we'll save this as municipality dot shp. So for the case of shp we are going to give the extension as .shp, and I will run the code. So after running the code, let me go to the output folder, and you can see here is the file of save file format .shp. And if you want to save this file as GeoJSON file format, so you can do what you can do is abc dot to file. So let me copy the same, this is the same, and you can remove this .shp file format and save as GeoJSON. And what we are going to do is driver will set this as GeoJSON, and also you have to give the encoding equals to UTF-8. This is the encoding. You might already you have seen here, I guess, encoding. So it hasn't shown the encoding, but UTF-8 is the encoding. And then enter. You can save the data into GeoJSON file format. Since GeoJSON file format is a large file format, it will take some time to save. So let me refresh this folder once again. Okay, you can see GeoJSON file format. And another way to save our data is we can save this as GeoPackage. So for GeoPackage, what we will go in GeoPackage, we'll save this as GPKG is the extension of GeoPackage. We'll go with GeoPackage GPKG, and you might have known that GeoPackage are different layers. So layer will be, what will give the layer? We'll give this as Palika will be our layer. So UTF encoding is same. Sorry, I guess encoding there's some, so I have to keep not given here comma. Okay, so once again I will refresh this folder. You must see one GeoPackage. Okay, so you can see GeoPackage as municipality. So in this way you can add GeoPackage file format. Now this way we have ended this session on writing data file format. Now we are going with the next session of working with the attribute data. Okay, now we are on the next session, that is working with attribute data. So what is attribute? You must know the concept of attribute. So here you can see in this data also, this is the geometry, that is spatial data that contains the location. Other than this all are the attribute data, that is type of the palika, now name of the palika, name of the district, the province name, and the province id, that is 1 to 7. These all are the attribute data. What attribute data gives it? It gives some emphasis to our it gives some information to our locations. So what is in the location, what that location refers, what that boundary refers, what that point or polygon or line refers, that is the attribute data. So what we are going to do is we are going to work with the attribute data. So for that case what I'm gonna do is I'm gonna create a new where we can see there are many district. So from this, what I'm gonna do is I'm gonna create a new shape layer or a file layer data frame that has only a single district from this whole municipality layer. I want to extract a single district from whole municipality layer, whole Nepal layer. So I'll extract Rupandehi district. So for that case, I will go to it, Rupandehi, and we have already imported our data as municipality. From municipality, what we are going to do is we are importing and extracting our Rupandehi district only. So inside municipality, what we have to do is we have to go with municipality, and municipality, inside municipality, what we are going is we are going with municipality district. So what it does it, this is the municipality layer. We are working on the municipality layer. Inside the municipality layer, what we want to search is municipality district is equals to Rupandehi. Okay, once again I will say we are creating a new variable that is Rupandehi, that is store the data of Rupandehi district only. So what we are going to search is we have to inherit all the data of the municipality that has municipality district of the municipality is equals to Rupandehi. Okay, so let me plot the Rupandehi dot plot. What it does is it will plot all the Rupandehi, all the municipality of Rupandehi. You can see all the municipality. Let me go with Rupandehi dot here. Rupandehi dot here. So what it does is it will add all the head of Rupandehi. You can see there are the Gaupalikas of Rupandehi, and let me get the length of Rupandehi. You can see there are 70 data in Rupandehi, and let me get the shape Rupandehi dot shape. Okay, 76. The number of features is 6, attribute data is 6, and the number of features is 17. And now let me plot him Rupandehi district according to Palika. So for that case, you have already seen there. Okay, so since we have many data, so we'll remove the legend, and then we will go with Rupandehi. Sorry, province. Since the province is same, it will give a single color to the province. Rupandehi dot okay, so I guess there's some, it hasn't plot according to Rupandehi dot plot column. Okay, let me remove this. Why isn't this showing? I guess, oh sorry, this district this Rupandehi is a district, so it will give the error. I guess I have to go with forgot. I'm sorry, I'm very sorry. This Rupandehi is a single district, so it will show a same color to the district. I must go with Palika. Remove the legend. You can see. Okay, it will give different color to different Palikas. This way you can visualize our data. Now what I'm gonna do is I'm gonna create a new municipality. So what I'm gonna do is I'm gonna first create a copy of the municipality. So for that case I will copy the same, or I can import this .shp copy, sorry, municipality 1 equals to geopandas dot read underscore file, and I'm gonna copy this. So this is I've saved this, and I'll go with municipality 1 dot head. It will show me the data. It is the same data. So what I'm gonna do is I'm gonna create a new column where I can add the year. After geometry, I will add a new column where I will give the area of individual palikas. So for that case, what I will go is I will first initialize a column. So for that case, I will go with municipality 1, and inside municipality 1 area, I will create a new column that's name is area, and I will give the data of each value in the area as 0 first. This is the initialization. Okay, let me again see the data. Municipality 1 dot head. Okay, you can see a column, new column where area is equals to 0. Now what we have to do is we have to give the coordinate reference system in order to find the area. If you haven't given coordinate reference system, it will calculate the wrong area. So for that case, what we are going to do is we are going to give the create a new variable underscore crs equals municipality 1 dot underscore 2 underscore crs. This will create a crs, coordinate reference system, of our data. We have created the coordinate reference system of municipality 1, and we have saved this in a new variable, that is municipality underscore crs. So for case of Nepal, we will use 32645. This is the coordinate reference system of Nepal. You can search on the Google and you can find the coordinate system of Nepal. Now we have converted this into this coordinate reference system. Now we are going to find the area, municipality underscore crs. Since we have saved this into this variable, it will inherit all the data of this municipality 1 to this municipality underscore crs. So we can use now municipality underscore crs area equals to municipality underscore crs dot geometry dot area. And for that case, what we are going to do is we are going to divide it by 10 to the power 6, and then click install. Now we are going to see the not here. So why we have done this 10 to the power 6 is our data is in normally in meter format. So in order to convert meter square format, so in order to convert meter square into kilometer square, we have converted this into converted it into kilometer square by dividing by 10 to the power 6. So I have given here mistake data underscore CIS. Okay, so now you can see the individual value of the data. Now what we're gonna do is we are gonna plot the individual palika according to our area. So for that case, what we are going to do is we will plot according to area. Sorry, I have given mistake name. Municipality.crs, and it has given the plot according to area. Yep, legend equals to true. So this is the according to area. This keeps according to the area. Now what we are going to do is we are going to with this we have ended our session on working with attribute data. So now we are going with working with geometry of the file. Okay, so when working with the geometry, what we want to do is we want to get some idea of the data what we are going to add on this file using Geopandas. So what we are going to add is point data. What is point data? When we have the data that is related with a certain point, that may be your location, the location of your tree, or a location of certain shop, restaurant, or anything that defines the location data, point data. And another is line data. Line may be road or river or anything that defines a long range of data. And another is polygon. Polygon may be your parcel boundary, your forest data, or anything that defines the boundary. So when we have many data, there are also a relationship between the data. So what it might be is you might have one data inside the another. In case of our previous file, we had a palika inside our district. We had many palikas inside of one district, that is contains that palika, sorry, district contains the palikas. Or maybe the district is tossed with the another district, one palika is tossed with the another palika, that defines the torches. And overlap in case of palikas or this boundary, there is no overlap, but we have many data that has the overlap, that falls within the two boundary, that content that is overlap. And another is line touching the boundary. So there might be a river or anything that touches that defines the boundary of certain two district. In that case, the line touches the boundary, so you can go with the special relationship. Okay, so for the special relationship, sorry, special working with geometry, I'll write first working with geometry. Working with geometry, let me remove this. Now what we are going to do is, for working with geometry, we will be using a library that is Shapely. So we'll import the Shapely library, and to create a point, polygon, and line, we are going to import from Shapely dot geometry, import point, line, string, and polygon. So the point will be used to define the point data, line string will be used to define the line string data, and polygon will be used to define the polygon data. So what is point data? Point data defined as only a single coordinate, a single coordinate. And line string is, we can create a line string joining two coordinates data. And polygon is a data that is formed by joining a multiple coordinate data. So for that case, what we are going to do is we are first creating a geometric object that may be point, line, or polygon. So for that case, I'll first create a point. So what we'll go is we'll go with the certain value of latitude and longitude and latitude. You can add your own longitude and latitude, but I will add, for this case I will add 1:1, 1 is, this is the first point, and line string, line string. And for line string, what we are going to do is we will define an array that has more than one point, and it will connect this array to form a line string. It will connect this point to form a line string. So we have 3 points, 8, and another is polygon. Polygon is equals to polygon. We can create a polygon by buffering the line. When we create a buffer, we can create a polygon. So for that case, we will be using line dot buffer. Buffer will buffer your polygon by 1. Will buffer 1, and we are going to run this code. So let me visualize the point. It is visualized as point data, and let me visualize line. This line and polygon. Poly is, let me visualize this poly. So when we form our data, that is we have created a data that a line that joins this 3 point. So this 3 point has the data from 0 to 5, 9 and 10, 8. So I want to show whether this point lies within the line or not. So for that case, point dot within, then poly. So if it lies, it will give true. If it does not, it will give false. Let me create a new point 1 equals to point 1, 7, and then point 1 within point 1 dot within poly point 1. So it will return false. So in this way we can check whether the point is within or not, or also we can also check whether the polygon or point lies or polygon contains point or not, by also using poly dot contain and then point. Contains, sorry, yes, this is true, it contains the line point. So in this way you can find the relationship between the attribute data, and then we'll create a new geo series. So if you want to combine all these data, point, line, and polygon, in a single geo series, or you have to form a single file that has this all three data. So we have to create a geo series. So for that, geo series will be gpd dot geo series, and then inside the geo series we'll create again a array that will store point -10, comma 15, and next as point 10 comma 2. So it will create a geo series of 2 point data. Again, let me add one more point minus 5 comma 16. So I'll visualize now the data. This will only show the data, not visualize. This is the point data, all three are the point, and this the type is geometry data. And then let me visualize gs.plot plot, and I will give the marker as asterisk. Asterisk is the marker, and then color, I will give the color as red, and then marker size equals to 100, and figure size equals to 4,4. Okay, and now you can see we have visualized our data. And I'll also show one more. I have already imported Rupandehi district as Rupandehi. Let me import one more district as Palpa. That is adjacent district. Palpa equals to municipality. Enter municipality. Yes, I'll copy the same code. Palpa. And then what we are going to do is we'll now create a new axis with first plot Rupandehi district, Rupandehi the plot, and we'll assign the figure size as 10:10, and we'll add a new file inside the same plot. This will show two individual district. This is the Rupandehi district 1, and another offside is Palpa district. Let me once visualize Palpa as well. Palpa dot plot. Okay, you can see this is the Palpa. The upper part is the Palpa, and the lower part is the Rupandehi district. So we can show both data in the single plot like this way. Now, in the third is find the Palikas having area greater than 50 square kilometer and plot them along with the legend. So find the area that is greater than 50 square kilometer, and find the plot the legend also. So you can find according to, we have already find the district according to municipality. Inside the district equals to Rupandehi. That way you can find municipality that area is greater than is 50. So that way you can do the area. This is just a hint. You can do it and send the code on the comment section. With this we have completed this session as well, but there is a bonus session as well. So in the bonus session, what I'm going to do is I will create a new dynamic map. We have all studied about the static map, above all are the static map, but dynamic map we can change according to hover, or we can zoom in, zoom out. We can create a dynamic web map using a simple library. That is, we'll first install Folium. Folium is basically used for creating a dynamic map, and Matplotlib and then map classify. will first we have to install all of these libraries using pip, and then import map classify, import folium, and import Matplotlib. So since it is a not the basic course, it is some extra bonus course. It might run in some of your laptop, so it depends upon the RAM of your laptop and the data that you are using. High data cannot be visualized in Jupyter Notebook, so I will use this data and rupandehi dot explore, so we can explore, and according to column we will be using it. Let me first use only explore. It will only show the data. Okay, now it has run, so you can see my data is shown in a web map format. And if I want to change the color of individual palika, what I will do is I will copy the code and I will give column equals to palika palika. Let me run once again. So you can see it will give different color to different palikas. It will change the palikas according to the color. Let me CMAP equals to what we have been using at CMAP magma. Let me try this also. I haven't tried it, but I'm gonna try this. Either this works or not. It has to work. Okay, yes, it works. So in this way you can change the color and visualize your map in WebGIS. So with this we have completed our first course on Geospatial Analysis with Python, that is vector file format. I will be bringing you the raster file format as well within some time. You can see here, you can see the palika label data, palika label legend also. I guess this course was helpful in getting some insight to using Python for geospatial analysis. So this is just the beginning. I want to say to all the people who have been watching this video, this is just the beginning. And if you have just thoroughly watched the video without coding, without writing some code, this video is not gonna help you. This is just one another random video that random video stream that you watch on YouTube that you will forget after 2 or 3 days. So I want you to write a code and share it with us. You can upload it in your GitHub repository and share the file on the share the link of the GitHub repository on your on my comment section. And if you have some problem with the exercises, I have given the exercises at the interval. So if you have some problem with the exercises, you have to uh, write the problem on the comment section. I will try my best to give the answer in the comment section, or anyone watching this video can give the answer in the comment section. Let's make this session an interactive session. Let's share this video. Okay, you can help me by sharing this video to your friend who are willing to learn this tutorial. I guess this is going to be a life-changing moment for you. You can get your career out of this tutorial. You can direct your interest on Geopandas using this tutorial. So this much for today, I guess. This is what I want to say to you. Get learning, keep learning, and share your uh, result with everyone. Sharing is caring, I guess. And Thank you very much.